All right, guys. Chapel day, let's go ahead and get done as much as we can. We're going to go ahead and grade section 11.2 tomorrow, 11.1 tomorrow. So here we go. Let's see what you guys are able to get done. We have parametric equations defining a curve. We have an equation. Oh, no, we're supposed to find an equation of the tangent line at the point -3, 8. So, you guys hopefully got here pretty quickly, right? Okay. What were you thinking about for that? And derivative, were you guys thinking about y prime of -3 over x prime of, now, hold on. Why do I need to go back and say not -3? I need of t such that t is equal to, just kidding. What do I know?
Nothing.
You know that y equals 8, so t cubed equals 8 and t equals 2.
And this will only be a problem if when I plug in over here, if I plug in 2, it doesn't work, right?
Yeah.
But what ends up happening with 4 minus 8 plus 1, there, what's t?
2.
So what am I plugging in? 2 y prime, which is 3t squared, over x prime, which is 2t minus 4.
Get the number of the 0.
I'm plugging in 2, yeah?
Doesn't work.
However, what's the dilemma if you end up with 12 over 0? The slope is undefined because it is a vertical tangent line, and any vertical line has an equation of y equals a or c or k or whatever you want to call it. No, not y. Y, you can fly. No, you guys never, oh, you didn't have Shanks. Never mind. Lo siento. He always say y, you can fly, and then it was, never mind. Horizontal line. Yeah. Y, you can fly, x, and you die. Just think. Kyle, y, you can fly. It's a horizontal line, and then x, and you die, like you're skiing. Pause! So therefore, in a way, could you put 12 over 0? I suppose. But what happens when you multiply by 0? Oh, and then you divide by 12. Well, it's nothing over 12. You end up with x is equal to -3.
Why isn't it 8?
Because when you solve, just think of it this way, that's going to be, if you multiply it by 0,
So you have to multiply by the other side. You can't just say, oh, well, it's all 0.
divide by 12. So x is equal to -3.
But you can't say because 12 is 0, like, doesn't it, like, destroy over the x minus x plus 3 goes away?
No, because I need x to correspond with that point. Does that make sense? Okay. Example 6. All right, calm down, my chatterboxes. The position of a particle moving in the xy plane is given by the parametric equations x equals y equals. For what values of t is the particle at rest? What derivative? Nope. Nope. Nope.
Oh, is it x? What time is it?
Is it when you eliminate the parameter?
Pause. You guys, I mean, you could kind of, but that's not going to help. Pause. Shh. If you set y prime of t over x prime of t equal to 0, aren't you setting dy dx equal to 0? Aren't you just finding the parts of the path that have a horizontal tangent? That means nothing in regards to your velocity and how fast you're going when you go on that part of the path. Does that make sense?
But then if you take the second derivative,
You don't want to take the second derivative. That'll show you the concavity of the path.
but isn't it like if the signs are different?
Why don't you take the horizontal velocity and the vertical velocity and say, well, horizontally it has to be stopped and vertically it has to be stopped. I'm not talking about a tangent line. I'm not talking about a tangent line. I'm not talking about for whatever curve I'm having. I don't care about when the slope is 0. I need the velocity. And there are, in an xy plane with parametric equations, you have a horizontal velocity and a vertical velocity. I need both horizontally and vertically. I need it to be stopped. Katrina, go ahead and ask your question as I'm plugging in.
But the derivative, dy dx, is y prime over x prime. So when you pitchfork, is that
The derivative. Except, Kyle, whisper. When you do a pitchfork, you have zeros and DNEs, and that's just talking about the slopes of the tangent line. So I guess your critical numbers will end up coinciding, but the problem is, in order for something to be completely at rest, I need any times where both are true. I can't just have one or the other. Does that make sense? Yeah. So therefore, you guys were hopefully factoring. You ended up with 3t, t minus 2. So therefore, horizontal, guys, it's really hard to talk over someone and not feel to some degree disrespected. And it happens over there, and it was happening right here. Just shush and let me finish the problem. You guys had your time to talk. Now it's my turn. 0, 2 are both times when horizontally the particle is stopped. True? And then as you come over here and you divide everything by 6, you could end up pretty quickly with a quadratic that you can factor. You end up with t minus 2 and t plus 1, which is t equals negative 1 and 2. And as some of you have already figured out, and great job doing so, but others were far behind you, the one time where the particle is completely stopped is at t equals 2. Some of you have a background in physics and some of you don't. Some of you, this is a very new idea because we haven't dealt with two-dimensional motion. Not really. So if we were just dealing with something that was moving up and down and I was dropping, for instance, a ball, and it went straight vertically down, when is it stopped? This would be f of x. The position of the ball would be f of x, right? F prime is how fast it's going, and I would just set f prime equal to 0. No big deal, right? But if I have something moving two-dimensional, like for instance, a ball that's moving, like being thrown, so it is going up, but it's also moving to the right, then that motion needs to be modeled both horizontally with the left-right motion and also vertically with the up-down motion, and that is what these two functions can do. They model for us horizontally how it's moving, where the position is, and vertically where the position is. And we could put those two in our calculator and see the actual path itself put together as to what track this position of this particle is moving on. But what we're caring about is when the particle is at rest. And so if I were you, if you were a highlighting, starring kind of person, I would, for parametric equations, highlight star at rest and make a note that you need both x prime and y prime to both be 0. Not dy dx, not the tangent line. So the first example was specifically a tangent line. The path, if you were, for instance, releasing at a certain point, where would the object go? That's the tangent line. That would be its trajectory when you released it. However, down here, when you're just asking about at rest, that's just x prime, y prime. We are not doing dy dx. Now down in number 7, when it asks for the second derivative, now what are we doing? We're just doing what they tell us to. We don't even need to worry about interpretation, whatever. It's like, okay, well, the second derivative, aka what Katrina was saying, we just want the concavity of the path. Just the concavity of the path. Has nothing to do, well, it does. It is related to the motion, of course, but just the concavity of the path. So therefore, Corey, this is the one you were doing. How did you go about finding the second derivative? Okay. So derive y over x. So y prime over x prime, right? Dilemma, kiddos. Am I allowed to plug in 1 right this second? Because if I do, it's a constant. Derivative of any constant is 0. That doesn't help me. Always plug in at the end, right? What did you guys get for y prime? And then x prime? Got it. You have options. Did anybody exercise that option? Yeah. Third, yeah. Or I guess if we want to, we will need to derive this again, so then we can go ahead and just get it back in that form. Now technically, when we cancel something out, we do need to at least be careful that we haven't changed the meaning at all. Do we realize that dy dx is dne at t equals 0. That's going to be a vertical tangent line. We did just take away that meaning, but I don't really think we need it. But there is a vertical tangent line at t equals 0. That's what happened by us factoring that out. But otherwise, all we need to do is now we have the dy dx. Noah said take a derivative. Do you guys agree? Okay, so we're going to do d dt of 2t squared minus 3t, which is going to end up being 4t minus 3. Thank you. Over. Because right now, all that we've done is we've taken d dt of a function, d dt of dy dx. But is d dt of dy dx the second derivative? No. For the second derivative, no idea why it's there. Don't I technically need d dt of dy dx? But it's like, wait, I need a dx, don't I? Okay. Well, I need a dx, and I just got an additional dt. Oh, maybe the notation makes sense. Maybe the formula makes sense. If I have to derive this guy with respect to t, oh, stink, I have a dt. Okay, get rid of him, and meanwhile, get dx. Okay. Just divide by what? X prime again. What am I plugging in? 4 minus 3 is 1. 2 times 1 is 2. Done. Interpret for me, because some of us were kind of weak on our last test when it came to AB knowledge. What does the second derivative tell me? Okay, so what about concavity? It's concave up. Oh, so therefore t equals 1 is a min. Not necessarily. You can only tell relative extrema with concavity at a critical number. What needs to be true? Critical number. What needs to be 0? The first derivative. So plug in and ask yourself, okay, is 1 a critical number? No. So, but I do know at 1 that the first derivative is negative. So I know that at 1, the slopes are, you can't say it is decreasing because the question is what? The y's are decreasing. You could say that. The function of y's are decreasing. It just starts to get confusing after that. Let's just pause and say it's not a relative min. But it could have been if that was 0. Kyle, what was your question before I change this line? Because that's what we solved for up here, and that was our 2t squared minus 3t. Oh, got it. Don't know why my board's being done, but it officially is, so that's good. Okay. Kiddos, this is the end of section 11.2. Thanks for letting us practice it a little bit further and hopefully answer 11.1. I apologize. Answer things a little bit more in detail. I do believe that it might be a helpful thing this year for us to make up a parametric motion card. I think that could be helpful with clues like at rest, x prime equals 0, y prime equals 0. Maybe something to do with trajectory, talking about dy dx. But I think I need to develop that a little bit more. But for sure, we do have one endeavor, right? Don't we have the length of the path? Okay, good. The length of the path is the same thing as arc length, however parametrically defined. And you guys are definitely able to practice that in homework on 11.1. We'll see what questions you guys have tomorrow, but for right now, let's start 11.2. 11.2, vectors. Dun, dun, dun. A vector has both magnitude and direction. The nice thing is, kiddo, section 11.2 will not be due until Wednesday. Definitely not tomorrow. Wednesday, actually maybe Thursday, to be honest. Thursday. Couldn't figure what out? Oh, I totally forgot about that. That's actually pretty. Before you guys could actually get it. Oh, you guys. So the distraction thing isn't new. I mean, that's good. That's All right, you guys just saw. Oh. I forgot that class. Okay. I mean, I remember the class. You guys need to remind me which is which. Just say John, and I got it. Okay. We've talked about this. Moving in the XY plane. We need like some therapy or something. I don't know what's going on. Okay, so moving in the XY plane. Moving in the XY plane. You guys just noticed in the examples. Okay, done. Done. No, it's not you guys. The board just keeps on getting worse, and I don't know why. No, it was literally like inches off, and it was fine just last period. All right, 11.2, vectors. You guys just noticed in the example right back here that it said moving in the XY plane. Okay, that's a huge hint on the BC exam. Moving in the XY plane. I know some of you guys are like, Psh, I'm just going to notice it's parametric. Well, I hope you do. I really do. I really, really do. But in AB, didn't we have functions in terms of t also? Yeah. Okay, so moving in the XY plane is going to be very, very helpful because that's going to be two-dimensional motion. That's where we need to be very careful with our parametric curves. You guys know, hopefully, somewhat. Did I not have any of you guys in pre-cal? Okay. 1, 2, and then 3. Okay. Oh, the poor little V. Okay. My vector is going to be in terms of a horizontal movement and a vertical movement. Was it V prime or was it just V? Okay. Remember, any vector is going to be a directed line segment. So for my few that I haven't had before, guys, just bear with us because I'm just introducing a lot, okay? A vector has both magnitude and direction. This little arrow does not mean going on forever. It is finite. It is stopped. It just denotes a direction of like a force or a direction of like a movement or a velocity or a direction of like a tension, a direction of work being done. It just does have a set length that's always at an angle. We can break down any vector like a diagonal, like a hypotenuse with its horizontal and vertical components. Okay, with that we can go ahead and say, oh, hey, it's already solved. That's no fun. Someone could put that up on the screen. That would be super, super helpful. Boop, boop. Sorry, guys. I actually had the notes already, but I forgot that my computer freaked out and shut down and didn't save any of the changes. So I want you guys to go ahead and take the following. Some of you have done vectors before, some of you have not. I want you to graph the point -1 root 3 and connect it to the origin. Graph the point -1 root 3. I know it looks weird with the carrots. We'll get there in a second. But graph the point, connect it with the origin, and try to find both the direction and the magnitude. I'll be back with you guys in just a second as I go make the changes that were supposed to have been done again. Back to the origin, yeah, since it didn't give us another initial point. So we're used to -1, whatever, as an x value. We're used to √3, whatever, as a y value. We could put the point right here, right? For that point, I said connect that point to the origin. If it does not give me a different initial point, I say the initial point is the origin, and it's headed towards the final point that was given to you in the component form. There's a ghost in the board, and I don't know what to do with it. Thank you for offering, not really time right now. And it's not really human. Anyway, so vectors are shown in what we would call component form. Component form uses side carets. The first part is going to be the horizontal. You guys just saw me orient this. I'm not going crazy. You just saw me do it. It was fine for like 2 seconds. Okay. So long story short, here's the picture of what's going on. But I can kind of just zoom in on it and say, hey, okay, so we have a diagonal vector which has a horizontal component of -1 and a vertical component of √3. Horizontal, vertical always hits each other at a 90-degree angle. So if I'm asking for magnitude, magnitude is the how muchness, is the greatness, is the quantity that goes with the vector itself. All we have to think about is, sweet, let's find, technically the notation would be double lines, let's find the magnitude of vector v. But guys, isn't it just the hypotenuse? So I could say the magnitude of vector v, which is like double absolute value lines, is equal to the square root of -1 squared. Such a struggle. It's okay. Lord's teaching me patience today. -1 squared √3 squared. Yeah, because we have 1 plus 3 is 4, and then that should be 2. That is what we call magnitude. Okay? But what else are we missing? Direction. Direction, just think angle to some extent. They might ask for it for different ways, but just think angle. So then angle, theta, can't I just make the angle, If I want to find theta, I could just do tangent inverse, thinking about I have opposite and I have adjacent. Remember, for any angle, the little reference angle is inside the right triangle that would connect to the horizontal axis. So I'm thinking about this angle, opposite over adjacent. I have tangent inverse. But here's the dilemma, kiddos. If you plug in tangent inverse, what do you get? Nope. You get -60 degrees or -pi/3 in a nasty decimal form. If you were to plug into your calculator, what's the dilemma with -60 degrees and the vector that we see? -60 is in quadrant 4. We need quadrant 2. Well, how do we get from quadrant 4 to quadrant 2? Just add 180. However, we're supposed to be in radians. So how about 2pi/3? It's a unit circle 1, you silly goofs. It's a unit circle 1. If we have a 1 and a rad 3, that's a 1, 2, rad 3 triangle. That's a 60 degree in the second quadrant. 2pi/3. Some of you might have said it before I got there. I guess you could, but in calc we never do. We did not get to the calculus of vectors. It's still coming. We have tomorrow to work on it. Anybody who did not finish your 11-1, get it done for tomorrow so we can grade it, okay? Bye, guys. Bye, guys.